Now this is on integration, which is completely the opposite of differentiation. So integration is completely the opposite of differentiation, and I'm going to urge you, if you don't know differentiation, you actually need the skills, you actually need the knowledge of differentiation in this integration. So as much as possible, try to revise it. And yes, one just quickly revise the basic rules of differentiation, so that integration will be much more easier for you to understand, assimilate. So it's also as easy as differentiation, just have to have the right mindset to learn it. So in integration, in integration, you know, in differentiation we are always giving like y is a function of x is a function of y, things like that. Then find dy dx, find dy dx of this. So when you are giving like x raised to power n in differentiation, it will be equals to n x raised to power n minus 1. So that's differentiation. Or when you are giving x raised to power n plus c, where c is constant, you are going to have n x raised to power n minus 1 plus 0, which is still the same thing as this first one. So although different question, but it's still the same answer. So that is how we do differentiation. Now integration is now the opposite. What if we are now given this? How do we come back to this? So that is integration. When we are given the answer to the differentiation, how do we come back to the differentiation? That's integration. Now integration follow this general formula, just like differentiation has this general formula. Integration also follow this general formula, which is x raised to power n. When you are given x raised to power n and you are told to integrate this, the general formula is simply x raised to power. Remember, in differentiation you are always minusing 1, but here you are going to add 1. You are going to have x raised to power n plus 1. And in differentiation you are always multiplying this n by the x, but here you are going to divide this n by the x, but it will not just be the n, it will be the n plus 1 again. So this is the general formula for integration. Whenever you are given x raised to power n, it's going to be x raised to power n plus 1 over n plus 1. Another important thing is not to add plus c. C is the constant, which you don't know. Remember that in differentiation your constant is always disappearing. So if your constant is 2, the 2 will disappear. So you definitely cannot know if a particular question or a function that you have to differentiate is actually having a constant or not. So that way we just need to assume there is a constant c in all our integration questions. So in all your integration solution, always add plus the constant c. So this is the general form for integration, and this must be added plus c whenever you are getting your solution. So just like differentiation, integration to also have its own rules. Okay, I think I have them here. So integration also have its own rules, the rules of integration. So they are quite simple, so just take note of them. So our rules of integration, the first one is the integral of a constant k. So if you are given a constant k, meaning you are given the number 2, for example, to integrate, you are given the number 5 to integrate, you are given the number 8 to integrate. So these numbers, these constants, are represented by k here. So if you are given a constant k, what is the integration of the constant k? So this simply means, and take note of this sign that they use for integrations, this integral sign, and we are going to have something like dx, depending on which, with respect to which particular variable. you are actually integrating to. So we have dx here. So you can actually integrate this constant to dx, this constant 2, sorry. So this constant k, why do we have kx here? Plus c is actually, we are putting a constant after it because that's the general rule of integration. Always add a plus c constant. Now how do we integrate this constant k? Let me use this 2 as example. For example, so this 2 actually means 2x raised to power 0. That's one thing you should know, because x raised to power 0 is actually 1 times 2 is 2. So can you see that they are the same thing? So using the rule of integration, it is actually going to be 2 times x raised to power 0 plus 1, this 0 please, over 0 plus 1. So this will now be 2x raised by 0 plus 1x is what? 1 over 0 plus 1 is what? 1. X over 1 is still x, so this is just 2x. So can you see that when you integrate a constant, automatically you are multiplying that constant by the variable. So that's how they get to this. So this is a rule you must always know. So when you integrate this constant k, it simply gives us our kx then plus c. If you are integrating this one, you have to add plus c. So that is the first rule of integration when you are integrating a constant. So the second rule is the integral of, or let me scroll down before I go to that first. So that's it. Okay, yeah, this is just the general rule that they have repeated here. So far n is not equals to -1, we are going to look at the situation where n is equals to -1 here, this place, when n is equals to -1 here. But now, so far n is not equals to -1, this is just the general rule of integration. What I just did just now, or the general rule I wrote in that particular whiteboard, is actually still the same thing as this. You just multiply 1 times this, it's going to give you the same thing. So this is the general rule of integration. So we have another rule here. Now if we are to integrate x raised to power -1, so remember that if you are integrating any x raised to power n, that's the general rule. So far it is not -1, but if you are integrating x raised to power -1, this is a special rule. It's actually just equals to in x, then you add your c. So integrating x raised to power -1 is equals to in x, then you add your c. This simply means when you are integrating 1 over x2 is also in x. Remember that x raised to power -1 is the same thing as 1 over x. But when you are integrating x raised to power -2, this rule does not apply. It's only for -1. So x raised to power -1 will always give you in x when you are integrating. So that's a rule you should also note that. Note. Then another rule here is when you have a natural exponential function, this Mr. E. So when you are integrating e raised to power k, that k can be any number 2, 3, 4, 5, 6, then x. It is actually just you dividing this particular function by this number k. That is it. Actually, when you are integrating e raised to power x, the integration of e raised to power x is still e raised to power x. This does not change. The same way, if you remember your law of differentiation, when you are differentiating e raised to power x, it still remains as e raised to power x. But if there is any number before the x, you have to divide this e raised to power 2x by that number. So that's it. Because actually, even when there was no number, there's invisible one. So you actually divide this e raised to power x by the invisible one, but because it does not have effect, that's why it still remains as e raised to power x. But if there's a number, if there's 3 for example, you have to divide by 3 when you finish integrating. So that's about that. So always note that, always note that. So we go to the next rule of integration. So those are those rules, you have to know them. You don't need to cram them, just solve as many questions on them as possible. You see that they will naturally be part of you. So the next rule is that the integral of a constant times a function. Yeah, this is also an important rule. So when you have a constant multiplied to a function, how do we integrate it? It's simply you bringing out the constant out, then you integrate the function. So that's simply it. So let's take an example. For example, you are told to integrate, if you are told to integrate x raised to power n, we all know what we have to do. We have to use the general formula. But what if this n now have a brother beside it, like 5? This x raised to power, let me do, should I do n? Let me do x raised to power 4. So you have to integrate x raised to power 4. So they'll put the x here like this. So when you are integrating, it simply equals to you bringing out this 5, then multiply by the integration of x raised to power 4. So by the time you bring out this 5, this 4. By the time you bring out this 5, you can now integrate your x raised to power 4 normally. And when integrating your x raised to power 4, it's simply x raised to power 4 plus 1. This 4 plus 1 is actually what? 5 over 4 plus 1 again, 5. Just always know that whatever is here is the one that is always here most. Is it most times? Yeah, let me just use most times in case. So it will not give x to the power 5 over 5. And remember, you still have the 5 here, so you still multiply it by that 5. But by the time you multiply it by that 5, this 5 will now cancel the 5. So now you need x to the power 5. And don't forget, add your plus c. If you actually do your work without adding your plus c, I'm sure the man might remove some marks, so it's not something you want to risk. Although the mark may not be tangible, but who knows what 1 mark, 2 marks can do for us at this moment. So that is integration of a constant times a function. That's an example. So another one is integral of the sum or difference of two functions. Yeah, this is actually simple. If you have two functions added together or minus, you are minusing them, what you just need to do is integrate each one of them. For example, you have integration of 2x raised to power 3 plus, can be minus 2, 4x raised to power 2 dx. So if you want to integrate this one, you just use separating them. Integrate this one separately, put your integral here to integrate this one too separately. So you use this normal rule we use here to integrate this one, you use for this one, and you are good to go. So that is just that particular rule, as simple as that. So we go to another law. Okay, which is like the last one here. Yeah, it's like the last one here. Now we want to integrate. It seems there's one that I don't have here that I may have to add. I'm not sure, I can't remember, but I'll think in case I see it. So the integral of a negative of a function equals to the negative of blah 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 blah. Yeah, this is actually saying, let me change my color. Okay, this is actually saying that, for example, if you are given integration of negative x raised to power 4, it's simply you bringing out this negative. You can bring out this negative out. Remember, your dx will be there. Bring out this negative out, then integrate your normal x raised to power 4. So just integrate that, then you are good to go. Then your negative will still be there. Then you put your negative back. So that's basically the rules of integration. That's basically the rules of integration. Yeah, I remember the one more I wanted to add, so that can be the next rule. So this rule is actually saying that, let me come to my Jamboard, my whiteboard. Please clear this. Now what this rule is saying, thank you. So what this rule is actually saying, there's a rule, it's called exponential function. So for example, if you are given integration of a, it looks like that's e, but this one is not e. E is like a constant number. We know that it has a fixed number, but this one, a can be anything. A raised by bx dx. So when you want to integrate this, how do we integrate this? That's the question. How do we integrate this? So it's different from the normal integration we have been doing, like a raised power. That one is like a raised power x. So we just say a raised power x plus 1 over x plus 1. But this one x, as in there is a number before it, which is the number that b is representing. So how do we integrate this? This one will turn to a raised to power bx, the upper one will not change, over b in a. So then you remember to add your plus c. So that's just it, as simple as that. So for example, we are given integrate 3 raised to power 2x dx. So can you see? So we are going to have what? 3 raised to power 2x over then your 2 in 3. Okay, now with that you are good to go. So those are the basic rules of differentiation, although I still have one more rule here, not really a rule, but it's just a method of differentiation. Integration, I said differentiation, integration by substitution. So it's a little complex, not difficult though, method which we are going to look into. But let's say and solve like few examples in terms with integration. Few examples in terms. So these are our examples here. We have 3 integrate 3 dx. This is a constant, so you are integrating a constant. Remember, 3 actually means 3x raised to power 0. So by the time you integrate, you are going to bring out your 3. Your 3 will stay alone. Then you integrate x raised to power 0. So that will now be x raised to power 0 plus 1, which is 1, over 0 plus 1, which is 1, which is the same thing as x. So your 3 that is staying alone, this is it, that is staying differently. Then your x that you just find here, this is it. Then you add your plus c. So as simple as that. So another integration, integrate x raised to power 2. So x raised to power 2 is just the normal differentiation rule. It's going to be x raised to power 2 plus 1 3 over 2 plus 1 3. Then you add your c. So that's how they get this. Mind you, this and this, they are still the same thing. X over 3 over 3 and 1 over 3 x over 3 plus c. They are still the same thing. So that's as simple as it can be. So let's scroll down and get more questions, probably tougher one. So let's take this. And mind you, these guys are using rule 1, rule 2, rule 3. The rule are not orderly. It's not that rule 1 must be rule 1, rule 2 must be rule 2. So you don't need to start saying rule 1, this is rule 2. No, you just leave that. Just apply your rule and move. So this particular question, I've integrate this particular one, 5x raised to power 4. So what you just need to do is to bring out your 5. Can you see they brought out their 5? Then they are now integrating just x raised to power 4. And to integrate, and it seems like I even used this as example just now. To integrate x raised to power 4, you just do x raised to power 4 plus 1, which is 5, over 4 plus 1, 5. Then multiply by your 5 that you have brought out. So this cancel this. So in case sometimes this one may be 3, for example, so it may not be divisible, as in just leave your answer as 3x, 3 times x raised to power 5, that's 3x raised to power 5 over 5. So we are good with that. Then remember to add your c when you are done with everything. So that's it. We go to the next one. So this one we have difference and sum. So we have to integrate 3x by 3 minus blah blah blah. So what you just need to do is to integrate them differently. You integrate 3x by 3 first. Integrate this one to differently. Integrate the third one to 1 differently. So this one actually have invisible one. We are integrating those 3 differently. Now these 3x by 3, they have applied this rule here. That's why we have it here. So they brought out the 3 separately and have x power 3. So before they now integrate, apply the rule of integration. So this x power 3 will now be x power 3 plus 1. That's 4 over 4. That's how they get this. Then minus, they brought out the minus outside. Then there's still invisible one. This invisible one, x, this x actually means x is power 1. So you add x is power 1 plus 1 over 1 plus 1, that's 2. So that's how they get these guys here. And this one that does not have x at all actually have 1. So that's 1 simply means 1 x is power 0. So by the time you say 0 plus 1 over 0 plus 1, it will give you x. That's how they get this x. So they arrive at their final answer. So the next example. Next example. Okay. So the next example is this. No, we have done. Okay, we have not done this. We have 3x raised power minus 1. Remember, minus 1 is a special case in integration. It's actually a special candidate, minus 1. So always know that minus 1 is the one that is leading to the in. Minus 2 will not lead to in. It's only minus 1. So how do we integrate this? To integrate this, you simply first of all bring out your 3 out like this. Then you face your x minus 1. So your x minus 1, whenever you integrate, remember the rule is simply in x. So that's how we get 3 times in x. Then you add your c. And it's simple. Isn't it? Simple though. So this now your integration. You're integrating this. So you're integrating this. This is the rule that I mentioned just now, the 10th rule that I did not include in that particular slide I showed earlier. So this is actually you integrating 2x, 2 raised power 3x. So you just use this rule, this particular rule, what I'm talking about, this one here. So use this rule. It's simply going to give you your question. Here is it. Just okay. This is it. So use this rule. It's simply going to give you your question back, and then this particular one will be up. Then you bring your 3 down here. Then in your 2. Then you add your c. As simple as that. And last but not the least, you have 9e raised power minus 3. That's also part of the rules of integration. Check above. We are going to see the rules again. So it's going to be okay. You see, I'll try and attach this particular slide that I just used. If possible, I'll just put the link in case it's needed, but I don't think it's really needed because everything is in trans. So just check trans. So this 9e raised power minus 3, just apply the law of integration. Bring out your 9 out first, then you integrate e raised power minus 3x. So the law of integration simply means this e raised power minus 3x will remain e raised power minus 3x in the numerator. Let's now be divided by this minus 3. Then remember to bring this on line that you brought out. So 3 here 1, 2 here 3. But remember this guy still have minus, so you multiply by this as minus 3 e raised power minus 3x. Then you add your plus c. So that's just that. So that is your answer. So That's actually the basic things you need to learn in integration. You still see some questions which will be a combination of just all these rules. Just try them out. So I'm very sure you are going to get them right. So there's something else I'm to mention here, the initial and the boundary conditions. Now this initial and the boundary condition is used for us to get our C. Remember that in the past we have been finding integration, we have just been saying plus C. Since we don't know what C is, C can be 3, C can be 10, C can be 100, but there's no way we can discover what C is. But with an initial and a boundary condition, we can actually know what exactly C is, and we'll be able to put it in our integration solution. So how do we know that? Now in the question, they will actually give you what to integrate, like you have to integrate this. They will not give you that if given that the boundary condition is actually y equals to 11, x equals to 3, you are now to integrate this. With this y equals to 11, x equals to 3, you'll be able to get your C. How? The first thing you do is to integrate this first. So integration of 2, which is a constant, is simply 2x plus c. Apply your law of integration, you are going to get that. So once you get 2x plus c, remember this simply means y equals to 2x plus c. Remember that. So replace your y with 11, replace your x with 3, so you can know that, you can see that it's only c that is unknown now. So by the time your y is 11 is equals to x is 3, that will be 2 times 3, that's 6 plus c. So what will you multiply by c? And what will you add to 6? That will give you 11, or just bring 6 like this, becomes 11 minus 6, which is 5. So our c is 5. So you now go back to your solution here, 2x plus c. You now put it as 2x plus 5. So now you know exactly what your C is, that your C is 5, because you are given a boundary condition. The boundary conditions, y is equal to 11 and x is equal to 3. So that's how to know exactly what your C is. So take note of that. So this is the integration by substitution, which is the next thing we are going to do. Then we go to definite integration. Then we end the integration there. You have to do the more work by just solving more questions, and in fact it's not really more work, just start solving questions. If you like music, just use your earpiece, be away from all distraction, listen to your music. I like Asha music, I just put my earpiece, listen to Asha music, I keep solving. You won't know by the time you solve 20, 30, 40 questions, you will not even feel it. I can even do that within 1 hour, at most 2 hours. You are done with what you want, and you have probably known it permanently. So that's just the magic of mathematics. You don't have to keep reading it over and over again. So now let's go to integration by substitution. Remember I said it's just little complicated, but it's still very simple. So we want to integrate by substitution. What does this really mean? There are some function that after you look, you still will not see which rule you can actually apply to them, because they are actually really complicated. So those are the ones we use integration by substitution for. There's even one that is integration by parts, but I don't think I'll bore you with that. I am positive that they won't ask that particular one, although it is also simple, but it is a little more complex. So that's that. But if you still feel you want to know it, you can just reach out to me. If when people say they want to know it, then probably I'll just do a very short video on it. But if it's just one person, probably I'll just meet the person personally if I am able to teach the person. And if there's none, then go for everybody. So don't worry, once you do not learn it, it will not come out. That's just it. So have faith that way. So let's move, please. So integration by substitution. So once you integrate by substitution, it is actually explained in these schwams. Very perfect explanation. But when you see a particular complicated either course topic, you have to do it in the complicated way. Now when I see that this particular stuff, whenever I learn it, I will forget. When the next time I'm going to do it again, whenever I learn, I will forget. I just decide to put it in steps. So in steps, I'm able to like get it perfectly. So that's what I'm going to show you now. The steps. So I actually apply them in steps. I put them into steps so that it can be easy for us to actually solve them. So you just know the steps, and also the steps too. You cannot actually say you know the step until you keep solving lots and lots of questions. So what are the steps? Now this is the form which integration by parts looks like. So where is my highlighter? So this is an example of a form. You can have different form. And the good thing is that sometimes they used to tell us integrate by substitution, and sometimes they won't tell us to. So I think in the past question did not see it. So, and this might be probably what we will see in our question if we are going to be doing integration. So that's why it's very important that you know it. So this is the question, for example. So I use this question as the steps. Now the step 1 is that let this bros here, we don't really have any issue with this first guy, because we can actually integrate. Suppose this second guy is not there, we can actually apply a law of integration. By the time we integrate this one will be 12 will come outside, and we integrate x is power 3 over 3. Chicken, now we multiply and we are good to go. I don't know their problem, but they have bring problem to us. What do we have to do? We have no choice. So but this guy here has spoiled the show. So because of that, we are representing this guy with u. So let u be equals to this guy here. That's the first step. So we now have integration of 12x raised to power 2 times u, because we are representing this guy with u, times dx. Now every of your symbols are important here. Don't forget to put this guy, don't forget to put this dx. They are very important. So we go to step 2. The step 2 is to find du dx. Now this your u equals to this, u equals to this, plus 2. You are now to find du dx of x is power 3 plus 2. So that's it. Now why are we finding du dx? We are doing differentiation inside integration. That's the life. So why are we finding du dx? It's simply because you actually have u here. You see that if you want to integrate with respect to dx, it is not really possible for you to do that here because of these two complicated stuff. So because it is not really possible, you now decide not to even integrate with respect to x again. You now make u to be equal to this. Now we are now planning to integrate with respect to u. That's what you are planning to do. But there's no way you just put u here and go and integrate with respect to u when this is still dx. If you want to integrate with respect to u, this must change to du. And mathematics is not just something you can just maneuver. You cannot take those and clean it and put du. How do you get to du? That is the question that you'll be asked. So that is what we now want to do. So we now know that our u is x raised to 3 plus 2. So the step 2 is that you should find the du dx of this x cubed plus 2. So by the time you find du dx, your normal rule of differentiation, normal rule, nothing special. So your du dx will now be equals to du dx equals to rule of differentiation. Alarm everywhere. Thank you. Yes, sir. So du dx, so will now be equals to 3x raised to power 2, your law of differentiation. Then these two will disappear because the constant is 0. So this is your du dx. So you have find your du dx. Congratulations, you have finished step 2. So we go to step 3. So step 3, make dx the subject of formula in this particular du dx. You want to make this dx the subject of formula, so it simply means you cross multiply. So you are now going to have, let me do it up here, 3x square times dx is equals to du. You never finish. Voila, no they finish. So you now divide both sides by 3x square. We are just trying to make dx the subject of formula here, over 3x square. So this one will cancel this one, so dx is standing alone. So dx is now the subject of formula, so we have du dx. Step 3 is done. Now step 4, substitute dx in 2. So we have now this particular place, this particular step 1. Remember that's where our real solution stop before we now branch to du dx. This one is just a branch. You want to go and greet Mrs. A, you now go and branch in Mrs. Big Shop. So that's it. So this one is just you branching. You are not really solving the question. So we are back to the question now. So we are branched to do du dx, and you are branched to make dx the subject of formula. So you now come back to your question. Now remove this dx. Let me clear everything so that I can see first. So remove this dx. I have cleared my answer to, and put this my answer here, and put du over 3x square, what we just got now after we make dx the subject of formula, du over 3x square. So you remove this dx and put du over 3x square. So that's how we have 12x square times u times du over 3x square. So that's just that. That's step 4. So we go to step 5. Don't be afraid of how long the step is. I actually make it long so that to make it as simple as possible. You don't need to know the steps offhand. It's not written the steps in front. No textbook write it the step, just to simplify it. So just follow the steps whenever you are solving questions. Try to solve as many as 10-15 questions. So by the time you follow the step in number 1 question, number 2 question, number 3, number 4, number 5, by the time you get to number 5, you see that even without you checking the steps, at least like the first 4 steps, you can already do it without even you thinking about let me go and check what is the next step. So that's it. So by the time you get to number 10, you might have known everything without even looking at steps again. So that's the idea. So the step 5 says divide any figure or algebra that is divisible so that the x is cancelled out, so that we'll be left with u. So what we are just trying to say is that anything, times that this is times, there's no plus in between them. So anything that is divisible, divide them. But note, du is like one particular, what will I call it? One particular term on its own. You cannot say u cancel u. No. D and u, they are together. They are traits that cannot be separated. So you cannot say u cancel u, but you can say x square cancel x square. I can also say 3 here 1, 3 here 4. So we are now left with 4u du. That's how we have this 4u du. 4u du. But note, if you see that x do not cancel out, it means either you are wrong or the question has no solution. Yeah, there are some situations in France like that they have to conclude that the question have no solution, because x is not cancelling out. After they cancel, there's still x here. So and you want to differentiate with respect to you don't want x to show at all. So it simply means you don't have a solution, or no key, you don't say so. So that's it. So if you just see that in this question, I don't think they want to give us a question that does not have solution, because we'll be stopping at a place where it will not be fun for them to mark. So once you see by pattern, you see that x is still there, probably you should be like 70% sure that you have done beautiful nonsense. But since it's still beautiful, just remove the nonsense, go back and check your nonsense.
remove the nonsense, then you'll be good. So we go to step 6. So that's step 5. So in our step 5, we are now at 4u du. So step 6, let's see what Mr. Step 6 asks. Step 6 is saying that now you can now integrate with respect to u. Now you have our u now integrate with respect to u. For u, just integrate like this is our x. Now u is standing like our x now. So when you are integrating for u, it simply means 4 will come outside, then it means u simply means u raised to power 1, which will now be u raised to power 1 plus 1, 2 over 2. Then this your 4 that you bring outside multiplied by it. So 2 here 1, 2 here 2. So we have 2u squared. 2u squared plus our c. Don't forget that Mr. C is when you get to this step 6, you are almost finishing. That's when you should start putting c. So this is now plus our c. So step 7, recall your u with the real value. Now that your is this step 1 or this step 2 that you said let u be equals to this. So go and bring that back this figure. Go and bring back this figure. Bring it back, recall it, and replace it in your u here. Let me select this guy. Replace it in your u here. So that's how we have it here. So instead of 2u squared, we have 2 the value of u then square plus 6. So you can check your answer by differentiating the solution. You can differentiate this so that you get back to your question. So that is integration by substitution. Integration by substitution. So I hope you get this. Can watch. I'm not going to do any other example because of time. So you can watch the video all over and over again for you to be able to get which part are you actually missing. So we want to, this is already 41-minute video and this video must not enter 1 hour. So we want to quickly go to the next thing, which is definite integration. Now everything we have been doing in integration from the beginning of this video is actually indefinite integration, because we are just using x, we are using u, we are not actually specifying what really is x. It's x4, it's x6, it's x this. So that's why they are majorly indefinite. And also we do not have a limit. That's even the most important thing. In definite integral, we actually have something we call a limit. Yeah, I think they use that English here too. Yeah, we have the upper limit and the lower limit. So can you see now our sign now has b at the upper part and it has a at the lower part. So those are the upper limits and the lower limits. Now this indefinite integral is nothing different from normal integration, just that we are just doing some substitution. All the substitution we do in GS2 and we just do it here. So you should be happy if you see a question like this. It's simple. So how do we do definite integral? So for example, we are given a definite integral like this. We are given integrate with 4 as the upper limit, 1 as the lower limit, 10x dx. Now this is just a formula. Not really a formula, don't worry, it's still a formula. It simply means whenever you are given a function and you have to integrate definitely, this is not indefinite integration. Now you first integrate this function. Just integrate this function. By the time you integrate this function, you will now replace your value of b and a into the function. After the integration, you will replace the value of b into the function. After the integration, you get a number, probably you get 20. You replace the value of a into the integration again, you get probably 10. Then now say 20 minus 10. That's it. So you now say 20 minus 10 and you are good to go. So let's use numbers. Let's just use numbers to do this. So we are given that we should integrate this. So first integrate your 10x normally. So that will be 10x is x is power 1. That's 10x is power 2 over 2. So 2 here 1, 2 here 5. So we have 5x is power 2. That's why we have 5x power 2 here. So we have integrated. So after integrating, that's when the integral sign will change to a straight line like this, just to show that you have integrated. If you go and put this sign again, you may go and integrate again mistakenly. So that's why we are just using a straight line. Then your 4 and 1. So the place starts with 4. You move x and change it to 4. So we are now going to have 5 times 4 raised to power 2. So that will be 4 raised to power 2, that's 16. That's 5 times 16. So 5 times 16 is what? That should be 80. So 80. So this first one here is 80. So you can do it step by step the way they do it. That's good for you. Then you put your minus. Then now do for 1. Remove the x and put 1. So that will now be 1 squared. That's 1. 5 times 1, 5. So this will now be 5. So we have 80 minus 5 sounds 5. So that's just it about definite integral. That's just this. The same thing you are doing here. You integrate this one separately, integrate this one separately, you get this, then you now do your definite integral 3 and 1. So when x is 3, you are going to get a number, that's how they get 1 weight. When x is 1, you are going to get a number, that's how they get 4. So 1 weight minus 4, give them 1 over 4. Okay, you are good to go. So apart from integration by substitution, this also another one that I feel might also be a question that will be asked. So I'm just going to stop at those 2 examples, then we move on. So there are some properties I think I should mention. In case. Now there are some properties of definite integrals. There are some properties of definite integrals that should be mentioned. So I may not solve questions on them, but I will just mention the properties and explain them. Now the first property is that reversing the order of limits, changing the sign of the definite integral. It simply means that whenever you have a definite integral for a function and we have the upper limit as b and a, you can actually interchange this b and a and make it a and b. But the only difference is that this one will now have negative. After you get your final answer, it will have negative. So the a can come up, the b can come down. But this will change to negative sign. That's just the first property. The second property is when you have the same upper and lower limits, your upper limit is the same as your lower limit. You simply means don't waste your time. This will be 0. That's just it. It simply means your final answer will be 0. So the next one is if you have, like, will I call it successive definite integral. For example, you have c and a. You have c and a as your definite integral. This can also be expressed as b and a, b at the upper limit, plus c and b. You get the gist, a, b, c. That's just this gist. Then a and b, b and c. That's just it here. So, but it simply means that a is less than b and b is less than or equals to c. A is less than or equals to b, b is less than or equals to c. That's the third property. Another property is when you have the sum or the difference of 2 definite integral with identical limits, the same upper limit and the same lower limit. It is equals to the definite integral of the sum or difference of the 2 functions. Yes, that's actually very logical. You have 2 integrals with the same limit. You can just what will I say, factorizing it. You can just do it directly. Add the 2 together, add this guy and this guy together. This it here. Then just pick one of these. You don't need to pick the 2 of them, just one of them. Then you do it normally the way you have been doing all the ones examples above. Then you are good to go. Then this. Now when you have a function multiplying, when you have a constant multiplying a function and you are still to find the definite integral, it does not stop this constant from coming outside. It will still come outside. Then you find the definite integral of this. So that's another property. So that's basically it. I'm going to skip this part because I don't think we are going to be asked that. Then we go to consumer and producer surplus, which is something I feel is also common. So consumer and producer surplus is simply you using definite integral to find the consumer surplus and the producer surplus. Consumer surplus, which is simply the price the consumer is expecting or willing to pay for a good. The difference between the price a consumer is willing and expecting to pay for a good and the amount he actually pay. I'm actually open or ready to pay 15 naira for a particular good, but as I go to the market, I realize the person is selling for 40 naira. Wow, thank God, 10 naira. You go back to the bank. So I skip my 10 naira. That 10 naira is my consumer surplus. So I am willing to buy for 15 naira, but this person is selling for 40 naira. So the 10 naira is my consumer surplus. So also we have producer surplus. Sometimes the producer will be willing to sell for a lower price, 40 naira, but the producer will now see somebody proposing to buy for, let's say, 60 naira. So 20 naira is the producer surplus. So this actually happens sometimes. It's a situation whereby, you know, when you need something, the value automatically increase. So in a situation whereby I'm selling a calculator, I am the producer, and the calculator, how much I did sell the calculator? I think 3,000. The calculator is normally 3,000 normal price. I have to buy a Mr. A and Mr. B. So two buyer comes to the market on Monday morning, this coming Monday. The first one is an economic student. Second one is a creative arts student. Now tell me, economic students, we are having exam on that Monday. Mathematics. Creative arts, I don't even think the person will use the calculator more than twice the whole of his program. So that particular person, probably he or she just need to calculate something urgently, and he's not with a phone, and he has the money to pay for a calculator. You may not even need it. It may just be that you want to buy it for somebody at home. So you just remember and he saw that calculator, and that's the only one that is available, and it's 3,000 naira. So by the time I tell two of you the price that is 3,000 naira, Mr. B will be okay with paying the 3,000 naira. So Mr. B wants to pay, and Mr. A needs it more than Mr. B because of examination. So Mr. A can decide to offer that, don't worry, I'll pay 3,500 for it. Mr. B may not want to pay that 3,500. He'll be like, what do I want to use to do? I just go and buy it somewhere else. So, but Mr. A actually needs it urgently, so he may be willing to pay 3,500 for it. By the time you pay 3,500 for it, that 500 is the producer surplus, because the producer is willing to sell at 3k, but he's not selling at a higher price with plus 500. So that's producer surplus. The same thing happens to consumer surplus. Sometimes the consumer may want to buy at a lower price, at a higher price, but the producer is now giving him at a lower price, 40. So you meet it in the market at a lower price, 40. So that's consumer surplus. Now they actually have a formula. This is the formula for consumer surplus. It simply means the quantity, equilibrium quantity though, and the zero. That's the upper and lower limits. Then the function that you are given, this is the demand function. Take note, this is the demand function because we are talking about consumer surplus, minus the equilibrium quantity again times the equilibrium price. These two are equilibrium price and quantity. Equilibrium quantity and price. Then this is equilibrium quantity. This one and this one will definitely be the same thing. Then this is the demand function. Now the same thing goes to this. This is for producer surplus. It has its own separate formula, similar but different. Now here we are minusing equilibrium quantity times equilibrium price, but here they will come before we minus. Then equilibrium quantity and equilibrium price minus the equilibrium quantity will be the upper limit. The lower limit is still 0. Lower limit is still 0. It's still weight at 0. Then the supply function. Remember, this one is demand function. This one is supply function because this is the producer surplus. So one question. I have 6 minutes more. One question. Then we end this particular video. So we are giving this question. Let me see. Is it consumer and producer? The answer is no. They are only asking for consumer surplus. I need one that is asking for consumer and producer. Wow. I'm just gonna look for sub questions. Wow. Now the time to search. Shit. King is consumers producer surplus. Is this giving me shine? This is just consumer surplus. Just producer surplus. Yeah, this is what I'm looking for. This is consumer producer surplus. So with this, you'll be able to solve anyone that just have one of them. Here we are given that the demand function PD is this. We are given that the supply function PS is this. So we are now to find the consumer and the producer surplus. That's it. Find the consumer and the producer surplus. Now the first thing is to find your equilibrium price and quantity. That's the first thing you are looking for whenever you are given this question. Find your equilibrium price and quantity. So in a situation whereby you are not given both function, that you are just to find one of them, they will give you the equilibrium price and quantity. But in this place, they won't give you, because they are doing the function, they expect you to be able to find your price and quantity with this. So your equilibrium price and quantity is just you equating these two functions. So by the time you equate, you'll be able to get your Q and your P. So our Q here is 4, our P is 9. So our Q is 4, our P is 9. So you need to quadratic and you do all those quadratic stuff. So although Q will give you two answers, but since Q cannot be negative, so you just leave that one. So our Q, equilibrium quantity is 4, equilibrium price is 9. So you now come to your consumer surplus. Take your formula and replace your Q. Remember that Q is the one up here in consumer surplus. So you replace it with 4. This one is always 0. Then this will now be your demand function. Your demand function. Don't make the mistake. Use demand function for consumer surplus, supply function for producer surplus. Your demand function here, this is it here. Then minus your equilibrium price 9 times your equilibrium quantity 9 times 4. So by the time you now solve this using definite integral method, that means you first integrate this one. When they integrate this one, they get this. They now find the definite integral 4 and 0. So this 4 and 0, by the time you find the definite integral, it simply means replace Q and put 4. Replace Q and put 0. But automatically this second one will give you 0. So by the time you are minusing, your answer will only give you the first one. So you now remember to minus this, your 9 times 4. That's 36. So that's how you get this final answer. The same thing we are going to do for producer surplus. Producer surplus, they are actually going to pick the producer surplus equation. That's the formula, which always starts with the equilibrium price and quantity, multiply them together, minus the integration of definite integration of Q will be the one up. Remember their equilibrium price and quantity is always the same. That one is their demand function that will not change. The function that will change, that one is demand function, this one is supply function. So the supply function, that's what you do here, and you do the same thing, you get your answer. So once you get your answer, you are good to go. So your consumer surplus will be this, your producer surplus will be 16, consumer surplus 42.67. So that's how we do that. So that should be the end of this video. So I wish you luck.